I come to Telegraph from time to time, from now and then. Now and then, it's great to be back. You know, I used to work in field, not far from here, and look, I'm fine.
But you weren't a rascal.
No, I was an engineer, not a rascal. I worked with rascals. We were required to have different colored hats.
It's kind of like Star Trek.
You can hardly tell us apart. I on Star Trek, roused about, engineering, it's just 6 of 1.
You didn't want to wear a red hat. Those are the guys who.
No, that was it. The red, yeah, he digresses, but the guys with the red shirts on Star Trek, they came to a bad end. But they're just characters, everybody. Relax.
Is this your first time visiting Science Museum?
Yes, in Oklahoma City, yes, it is.
It's quite a place.
Oh, it's gorgeous, you guys. It is, with respect to the other science centers which I visited, this is pretty great. This place has a lot of just fantastic innovations.
I'm amazed because the other science museums that I've been in, usually about half the exhibits are non-functioning, and they all seem to be working here, and everybody's having
maintenance. Yeah. Your admission dollars at work.
We got a little bit of a chance to look around. I think you got more of a chance than me. And I know, in fact, right backstage here is something that you love to make use of. It's
the vortex scanner.
Yeah.
So for those of you, for some reason, have not taken fluid mechanics, the vortex scanner is fantastic. It's, the motion of fluids, anything that flows is a fluid. So air is a fluid in the mechanical engineering world. And there's this mythic thing where you imagine an element of fluid, a cube of fluid, flowing through cube stream space. And then it devolves into this wonderful thing called the Navier-Stokes equation, named after Steve Smith. No, named after a guy named Navier, a guy named Stokes. And when you do the vortex scanning, all these complex mathematical terms all cancel out, and you get these perfect circles. Perfect rings. It's so cool. But I've grown out of it.
I'd like to see you do that on stage.
I was kidding. You never grow out of it.
We're going to
It's a radio show, but imagine. So one here, the second sound is the Kaplan. The first sound is the vortex. And if it's really far away,
it's like being there.
Yeah. It's almost.
We're going to bring out the first two guests for the show, but not just yet, because there are a lot of people here who, incredible as they seem, have not heard of the Planetary Society.
That is just weird, Matt Kaplan. Planetary Society is the world's largest independent space interest organization, advancing space science and exploration, so that citizens of the world will know the cosmos and our place within it. Go ahead, close the elevator door. That's my speech. So what happened was I finished my mechanical engineering requirements. I took one class from this famous professor named Carl Sagan. Carl Sagan. He and his colleagues felt that public interest in space exploration is very high, but government support of it not especially high. This is in 1980. When disco was giving way to new wave and punk, the important work of Sid Vicious and the Sex Pistols, that was a real band. Most of those guys, died of overdoses the way you do. When you live that way. But at that time, it was just this wild time when the Vietnam War was resolved. The Apollo space program had been wound down to some extent because the president was concerned about astronauts dying in space. And so Carl Sagan, Bruce Murray, and the guy Lou Friedman, who was a orbital mechanics guy at Jet Propulsion Lab out west, decided that they needed to start a society. And I joined in 1980. And then I'm a charter member, we checked it, and then Carl Sagan's kids watched the Science Guy show. So I got asked to be on the board of the Planetary.
Oh, wait, he was also your professor.
Well, I took one class. Yeah. I took a freshman astronomy class as a senior in college. I could handle the math. Good. And then his kids were fans of the show. I joined the board of the Planetary Society. Then I left the room at a board meeting, and now I'm the CEO. They took a vote. Boyd is not in the room. And so what we do, you guys, is get people around the world engaged with space. If you want to do something about space exploration, if you want to be involved, the Planetary Society is for you. If you want to do more than just read about it, if you want to contribute to shaping space policy, this is a big thing with us. We have a full-time person in Washington, D.C. We have a full-time policy analyst. You know, all the money that's spent in space is actually spent on Earth. Whoa, dude! That's right. And what we want to do, for me, well, first of all, overall, the Planetary Society wants to explore planets, to learn more about planets in our solar system and deep, deep, deep in space, the exoplanets, as we commonly call them. But for me, personally, myself, there's two things I really want. First one is let's not have the Earth get hit with an asteroid. This would be a very low probability event in your lifetime, but very high consequence. Like, that would be the end of everything you know, for example, which could be bad. So we guarantee you the Earth will be hit with an asteroid. Just when, nobody knows when. So when I was in class, Carl Sagan talked about the Tunguska event, as it's called nowadays. It's often called the Tunguska airburst. This asteroid hit the atmosphere so hard.
How hard was it?
It was so hard that it exploded and disintegrated before it hit the ground. It blew down trees 100 kilometers, 60 miles in every direction in Siberia. By the way, if you're an asteroid and you're coming in at the Earth from the north, from what humans call the north, you'll probably hit Russia. It's just, there's so much of it. Yeah. And so then the one that you may remember, just 2013, in Chelyabinsk, Russia, an asteroid that's not very big, but there's this huge streak in the sky and blew out windows. So this is the kind of thing that you just wouldn't expect. So everybody's looking at the streak in the sky, everybody's recording it with their dashboard cameras in their cars, and then a couple minutes later, this big puff of supersonic air hit the ground.
Just like that candle for the vortex.
So it blew windows into people's faces, and there were 1,000 people that went to emergency rooms in Russia because of the lacerations from broken glass, mostly. And just think if this thing had been twice that big, 5 times, 100 times that big, it would be catastrophic in a way that's hard to describe. If it hit Oklahoma City, that's it. There's no more Oklahoma City. And then the other thing that I really want in my lifetime, while I'm alive, is finding evidence of life on another world. So, it would be pro-flippin' found, if I may. If we found evidence of life on Mars, if there's like a microbial mat fossilized on Mars.
Not this mat.
No, different mat, yeah. Good question. Matt spells his name with one T, just like at the front door. Coincidence? Yes, actually, it's a coincidence.
People walk all over me.
I get it. Yeah. So, if you have, so Mars is much smaller, or somewhat smaller than here. So it cooled off faster. You know, a small pan cools off faster than a big pan on your stove. It cooled off maybe 1 billion years before the Earth did. It formed an ocean and atmosphere 1 billion years before the Earth did. So if you have an ocean for 1 billion years, maybe you've got something alive. And then the oceans evaporated, actually they got scraped off and blown into space by the particles streaming off the sun. But if you are a microbe on Mars, hypotheoretically, and that's a joke, hypotheoretically, it's a really funny joke. If you live under the sand on the ice that's on Mars, water ice, maybe you're still there. Maybe there's a colony of microbes still making a living on Mars someplace. And if we could find that, it would change history. It would be, everybody would just have to think differently about what it means to be alive. Are those microbes just like us? Do they have DNA? Or are they a whole different Martian, Mars-crobial deal out there?
Second Genesis.
Second Genesis, right. It started in a different way. But what if they're, wait, what about this? What if the microbes on Mars have DNA? Does that suggest for sure that life started on Mars 1 billion years before it started here? Mars was hit with its own asteroid, and then what's called a Holman orbit. These rocks came from Mars to the Earth. Of course, it's in space, man, so there's no noise. It wouldn't be, it would just be. And then land here, because there's a lot of Mars, if you know where to look, you can find Martian meteorites here on Earth that we can show that they're from Mars. So are we all descendants of Martians? Whoa, dude! So the Planetary Society connects you with issues like that. And we have learned opinions. We have the best, I think, the best long-form journalists about space in the world right now. Our board of directors is made of extraordinary space exploring people. The patent holder on Sirius XM radio, the world's foremost historian, people that have been involved with all sorts of space missions, guys who take pictures on Mars, pictures of Europa, the moon of Jupiter, with twice as much ocean water as the Earth. So the Planetary Society connects you with space. Check us out at planetary.org, your homepage. I mean, after you, of course, are at bill9.com. Yes.
And that URL is going to show up again up here on the screen.
So if you're listening at home, look for it on the screen.
Yep. They already know.
Or in the car. Yes, lead on.
All right. We are, as I said, at Science Museum in Oklahoma. And prior to the beginning of the show, we got an introduction from the woman who runs this place, the president of Science Museum Oklahoma. And she's going to be the first of the guests that Bill and I host here on her own stage, so I don't know who's hosting who. Sherry Marshall is the president. She's a native Oklahoman. She also recommended to us as somebody that we might want to have as a guest, the person who's going to follow her on stage, but he'll be up in a moment. Please welcome Sherry Marshall. Okay. Hey, thank you for doing this, first of all.
Oh my gosh, thank you guys for being here. It's what an honor to have you guys at our own home.
It's beautiful. Really, you guys have visited a lot of science centers. This one is extraordinary. It's great.
Thank you. That means a lot. I'm kind of partial that I have to 100% agree with you.
No, it's innovative. It's cool. And as Matt pointed out, it's very well maintained. And that's management, Sherry. Blow it up.
That's right.
If you're listening on the radio, you just say,
how many of you out there in the audience, if this is not your first visit to Science Museum of Okay, great place. During the little press briefing that Bill was doing backstage, you got a question, Bill, about how did you become excited about science? And it was kind of in a place like this.
Oh, very much in a place like this, yeah. It was the Smithsonian in Washington, D.C., which is cool. It's big. And has all kinds of cool things. But back then, there was hardly anything you were allowed to touch.
Yeah.
There was very, very little hands-on informal science education. Now the Smithsonian is, in many regards, stepped up to catching up with Oklahoma City as best they can. But this is what makes this place, seriously, this is what makes this place great. So welcome, everyone.
And for me, it was the Griffith Observatory on the hilltop in Los Angeles and the Museum of Science and Industry, which got me into all of this. You're a native.
Yes, and for me, it was Omniplex. You know, I came here.
Which is the original name of this place,
The
right?
original name of this place. It opened opened in this building in 1978. It actually started on the fairgrounds here in Oklahoma City. And then we built this big, beautiful, huge building, and it opened in summer of 1978. And I was one of their first students through their summer camps. And I realized—
Wow, you're an OG.
I am old, I think is what you're trying to say.
No, for the grown-ups, it's the original gangster.
Yeah. When it comes to science and gangsta, I'm all in.
Yeah. You went to
She's got the roots.
I went to BSU, blow stuff up, you know, right?
Not Boston State. Blow stuff up.
Yeah.
You've got so much going on here. There are many different exhibit areas. What is related? What do you have that's related to what we're talking about today? Space, astronomy.
What don't you have?
I mean, science is everywhere, and you know, you can relate to a lot of the things that we have in our everyday life, honestly, came from space exploration. But specifically to that content area, we do have a planetarium. We have a large space area where you can explore aviation in space. We have one of the original Apollo mission simulators on loan from the Smithsonian because it's obviously better here. No, that's not true. Love you, Smithsonian.
May I briefly, I think, a brief story about Rusty Schweiger, who was he's an Apollo astronaut, still very active, in fact, in the search for asteroids, and we're going to keep one from hitting us. But there's an Apollo simulator in San Francisco, or Oakland. And a guy I went to college with is the president of the American Pinball Association. And he prides himself on this sort of thing. So he walks up to the simulator, and he plays it, and he can sort of get it to land on the moon most of the time. Rusty Schweiger, 40 years after flying, walks up to it, boom, bang, and lands it right on the moon. Muscle memory, the number of times those guys must have rehearsed landing on the moon. It's really extraordinary. So come down to Oklahoma Science Center and see if you can land on the moon for reals, for simulated reals.
You said you have a planetarium.
We do.
What? Big changes in
Big changes. Actually, we started on the fairgrounds as a planetarium. And when we relocated here at our current location, we thought it was very important. Our founder had the Kirkpatrick Planetarium. And we've had this equipment for ages. And we realized that, wow, people care about this stuff. It's important. It's relevant. We need to invest in it. And so we have a plan now to move our current planetarium, which is a 40-foot dome. You've probably walked by it in our museum. It's right in the middle of our exhibit floor. A lot of places have planetariums tucked away off to the side. Ours is smack down right in the
We're
middle.
probably 15 meters. Yes.
Yes, I'm sorry, you're correct.
I forgot about this whole thing.
That's right.
I kid.
No, you're right, though.
I'm fooling around. Go ahead.
That's good.
We're going to move it.
Now I'm going to have to start doing conversions in my head. Thanks for that.
Well,
That's why you're here.
From a pretty small thing to
To a big thing, right? We're going to increase the size of our dome, and we're going to put it off to the side. Because it is such an anchor to our building. We're putting it where we have one of the large domed theaters, an omni-dome theater.
Yeah.
So a lot of museums around the nation have those. But they're becoming a little less technology relevant, whereas
less technology relevant.
Technologically relevant?
No, in other words, they're too dim and the sound's not as cool as I can see that.
What is that?
Yeah, what is it? Where are we? No, I mean, what's the neighborhood we're in?
In the Adventure District?
Adventure District 64.
Right.
Movie complex.
Exactly. Yeah, it's hard to compete.
128.
Yeah, it's hard to compete when we have movie theaters that can keep up with the bright screens and the digital. And so we've decided, you know what, that space is way better served with bringing
conventional theaters, so you're going to have a planetarium.
We're going to increase the size, put better projectors in there. We're going to be one of the only digital optical hybrid systems around.
So you'll have the old-fashioned type projector, the kind that I fell in love with at the Griffith Observatory. It was a Zeiss.
A Zeiss. We might have a Minolta, we might have a Zeiss.
Yeah, but you'll combine it with the new digital technology.
Right. We call it a digital hybrid or optical digital system, hybrid system, because those optical stars are so bright. They're actual pinpoints of light.
Yeah.
And it's not a digital representation of light. You know, you can say it's 4K or 16K or something, but it's still digital.
There's still pixels there,
on the screen. So when you have a true light bulb projecting on the screen, you're going to have a much higher resolution
Just
star.
sharp.
They're
Yeah.
sharp. They're beautiful.
Now, is this a true fact or a false fact? That's a joke. that you can take binoculars and.
Absolutely. So the resolution when you get from these optical stars, so you go out, the lights go down, you have that ooh moment, you can actually pull out the binoculars and see even deeper.
So for listeners around the world, we are in Oklahoma, right in the middle of the United States, which is right virtually the middle of North America. You may think that in this area with all this agriculture and so on and oil fields, that you would just be able to go out at night and see a tremendous number of stars. But for our listeners who might have pictures or images of the Earth at night, look for Oklahoma City. It is one bright, enormous metropolitan complex with a great deal of what we would call light pollution, extra light at night. And so to students who might live around here, I really encourage you to, families, everybody, come down and look at the new planetarium, because I'm sure, you are missing a great deal of the night sky, which might surprise you living here in Oklahoma City.
Yeah.
I think one of the moments that's really transformational is when you go into a planetarium and you see the night sky, and then they take it to a truly dark sky, because you can do that in the planetarium.
Yeah.
Take all that light pollution away, and that's when you get that,
yeah, people think it's a hoax.
Right.
It is one of the most dramatic experiences. We're going to introduce someone else. Before we do that, though, a little breakout here. The audience at home won't hear this. Pull your microphone down a little bit. That's more like it. Yeah, closer to your mouth. That'll improve the EQ a little bit. Okay.
You want to get high?
Yeah.
Still funny to me. Every week
Anyway. Okay, we'll pick up here. I have many reasons to be, we have many reasons to be grateful to Sherry. One of them is, as I said, the guy that we're going to bring out now, who is Bill Moore, who is, I guess, a great resource for the museum as well.
Yeah, he is a great resource, a great friend of the museum, and one of the best historians for space information that I've ever met.
Well, and I have proof of that. Sitting next to me here, which I'll show off in a moment, Bill Moore, he is a historian, maker of documentaries, author who founded Motion Picture Archive at the Oklahoma Historical Society. He is, among other things, the author of that book I mentioned, this magnificent book, which is called Oklahomans and Space, Chronicles of the Amazing Contributions of Oklahomans in the Aerospace Industry. It is really spectacular. This is my copy. You can buy one right here at Science Museum, Oklahoma, and I know that Bill told me the proceeds all go back to the museum. But don't buy a copy just yet, because we're going to be giving one away at the end of today's program. It is signed by Bill, and I believe also by someone else.
By General Tom Stafford, a native Oklahoman astronaut.
Apollo 10 astronaut. So, all right, please welcome another Oklahoma native who calls Oklahoma City home, Bill Moore. Welcome. Have a seat. This really is, it's a heck of a book. I'd use stronger language, but we have kids in the crowd. Yeah, it is gorgeous. I mean, I'll just give you a little peek inside. You were telling me this wasn't the original plan, because it complements a project you already had underway.
What began this project is I started interviewing Gordon Cooper when he was in this facility back in 2000. He was doing
It was Gordon Cooper, he's an astronaut.
astronaut from Shawnee, Oklahoma.
There you go.
Just east of
And this
Oklahoma
is the
City.
guy well known for scuba diving.
And I think,
Scott Carpenter.
Yeah, maybe Gordon might be a little bit better known for Mercury astronaut, but
But this is the guy that's called Gordo.
Gordon.
yeah.
And he landed, or he came to Earth on an ocean quite a bit downrange from the original plane.
No, that was Scott Carpenter.
That was Scott. See, it's a
Yeah,
blur.
yeah, you're close.
That's what he is.
That's right. We should write a book about it.
Well, it started there anyway.
Yeah.
And
And it began with that interview, and I realized that we needed to get all the other astronauts. And from there, I took off to engineers, media folks like Jim Hartz, who was, his interview was brilliant. I loved his interview. it just tells the story of the space race and the history of the space program up to today through the eyes of these Oklahomans.
So I was under the impression, and you correct this right up front in the book, that Oklahoma was the birthplace or home of more astronauts than any other state. Not quite true, but there is a great distinction for astronauts in Oklahoma.
There is. I researched that because I've heard political types, promote that about Oklahoma and tourism type folks, and it's not true. I imagine Ohio probably has more. I haven't really connected with all the shuttle astronauts since then, but
Well, Purdue University just keeps cranking.
Purdue, yeah, a lot of.
But right now, the administrator of NASA is a good Oklahoma.
Yeah, former congressman.
That's right. That's right.
Let me see where I'm going here. The book you said came a little bit later because somebody said, "Hey, Bill, you really need to do a book about all this."
I was putting together this series, this documentary series, which aired on our PBS affiliate here in the state, and we were going to have an event to celebrate this and bring all the Oklahomans in that I interviewed, and the executive director told me that we needed to have a book, and so I made this as complimentary to the interview process because they tell their own story in the video, and the book needs to tell the statistics of where, when, why, and how.
And it does very well, with great illustrations. I got away from where I wanted to go, which is also right up front of the book, having to do with the pioneer spirit, which certainly the first Oklahomans had. I would probably say the Native Americans as well, because they had to have the pioneer spirit to make it here from where we all came from in Africa, but also the settlers who came here. Do you see that same pioneer spirit exhibited in not just the astronauts, but the others who you documented in the book?
I did.
Bill, if you said no. Did the astronauts have pioneer spirit? No.
I have an idea where it was going.
I was afraid that the show would go too long. But yes, the astronauts, like a great example, Tom Stafford. His mother came to Oklahoma in a covered wagon to her dugout in western Oklahoma, and she lived to watch her son orbit the moon on color television. Now, I don't know, maybe...
That's astonishing, really, it isn't it?
Can that ever happen again?
Yeah.
That kind of technology change is just amazing.
Well, maybe. I mean, just to change the subject back to me. No, so my grandfather was in World War I on a horse. But now people ride horses, but for very different reasons. They don't conduct battle on a horse. Now battle is conducted on a laptop. So there's been huge technological changes, but as far as I know what you mean, transportation changes, yeah. So the audience members here are very well, I mean, this is not crazy. You may be the last bunch of people that learns to drive a car. I wouldn't be surprised if you are, though, that most of you will not learn to drive a stick shift, a manual transmission, because nobody will let you anymore. The engineers and car companies take the humans out of it. And I can easily imagine a time when people just don't learn to drive at all, because you let humans drive cars? Whoa! There must have been wrecks all the time. Yes, there were. Wrecks all the time. And to the young people here, I would say, I really hope you can address the problem of air transportation. Air transportation takes a huge amount of energy, a huge amount of kerosene, fossil fuel. And I hope you all can come up with just improvements to that. So I think it's very reasonable, SpaceX, this big company, is proposing that we get from city to city in rockets. That would be cool. Speaking of talking about flying cars, heck with that. I want to go London, I want to go Oklahoma to Sydney, Australia in 45 minutes. Come on.
Amazing.
But you have to qualify to take the PGs.
I'm ready. Speaking of air transportation, we have a picture of General Stafford up here, but I'm going to back up a little bit to a guy who certainly exemplified that pioneer spirit in Oklahoma. This is Wiley Post. You all know that he wasn't born in Oklahoma, born in Texas, right? But
That's not far.
oh, yeah, spent most of his life here. Absolutely amazing character. And this particular picture is particularly significant. Why, Bill?
It is. He created his airplane, the Winnipeg, could not be pressurized to go to higher altitudes. So he had to pressurize himself. And this was the first high altitude pressure suit. And Wiley Post developed that here in Oklahoma in conjunction with the B.F. Goodrich Company. And
The rubber tires.
rubber tires. It has a rubber liner inside. And he would pressurize himself to go to high altitudes. He discovered the jet stream. He was pretty impressive. And Tom Stafford told me that when he put on his spacesuit, he'd always think of fellow Oklahoma Wiley Post.
Yeah.
You guys, if you can't see the picture because you're listening to the podcast, that's kind of a joke. The guy put on a big can on his head with a very small round window in it.
Yeah.
And
this is the third generation model.
They tighten down a bunch of wing nuts. I mean, once you're in this thing, you're not getting out of it. There's no seat, there's no peripheral vision, nothing. But he trusted the numbers, as the saying goes, and was able to fly at these very high altitudes. It's like when you dive to the bottom of the pool, you feel the pressure on your ears. Well, we all live at the bottom of the atmosphere pool. If you go up high enough, there's nothing to breathe. And so you got to put on a pressurized suit. What an idea.
Amazing.
Yeah.
What a risk taker.
Basically invented the spacesuit. Bill Moore, I have to use the last name as well, otherwise there could be confusion. Bill Moore, you gave me several other great slides that we're going to try and get to, but I threw one other in, I threw Wiley Post in, because I just thought, we only lost him about a month ago. Another Oklahoman is Owen Garrett, the great space shuttle astronaut. He did other stuff too.
Yeah.
Was with NASA a long time.
Brilliant man, very, very nice, very kind. He was very proud of his son, Richard, when I was interviewing him for this program, because Richard was just getting ready to go up into space himself. So
He paid his way.
He paid his way. He told me that when Richard was growing up, he really was disappointed when he found out that not everybody got to go into space, because their neighbors all around him were astronauts. Of course, Dad was an astronaut, and so he eventually was able to pay his way and go into space.
Yeah. And I know that's something you'd like to do, Bill.
I would. I'm counting on space next.
I'm thinking of the other guys.
Oh, yeah, I applied
Both of you. Yeah.
I applied 4 times to be an astronaut. You know, has anybody applied to be an astronaut? Yeah, so they take out the clipboard, how many PhDs do you have? You know, what? The first one, 100 to 300. The kind of people that become astronauts are just these maniac overachievers. How many marathons have you run this month? What? And there are people that are able to do these extraordinary things, and then we count on them to make decisions that are important.
Here are some of those overachievers. That's Tom Stafford. Here are some of those overachievers. That's the Mercury 7.
Original 7 astronauts.
Yeah. Why did you want to show this off?
Because Gordon Cooper was a member of that group, and this is something that we can brag about as Oklahomans. Starting with that group of 7 astronauts, Oklahoma astronauts have been in every phase of the space program since Mercury. And where the last state kind of dropped off was in the Skylab program. And of course, we had 2 Oklahomans at Skylab. So we've had Mercury, Gemini, Apollo to the Moon, Skylab, Apollo Soyuz. Then Fred Hayes was not an Oklahoman, but he obtained his engineering degree from the University of Oklahoma, and he flew in the Oklahoma Air National Guard.
Oklahoma owns come on.
Yeah.
Just owns the space program.
and Fred flew the Enterprise, the test.
Yeah. I
shuttle.
might have watched him do one of those drop tests out at Edwards Air Force Base.
And Fred told me that he was more afraid of failing at that than he was in Apollo 13. And that was because he said it was the only test vehicle. And if he had crashed it, cracked it up, there wouldn't be another one, and he didn't know what it would do to the shuttle program.
Whereas, you can wreck an Apollo spacecraft, that's fine.
Well, he brought it back. I guess that's why they thought he was the right guy for the job.
Fred Hayes, I know we have worked with him, but he just told a story that just utterly fascinates me. So these guys on Apollo 13 were coming back, and they were cold. Because the systems are shut down, they're trying to save electricity, they don't want to run the batteries down. This is before spacecraft just had all kinds of solar panels flying on them. So he found that if he balled himself up and arms around his knees kind of thing, he could keep warm if he held really still. And this is a fantastic insight in physics, and it has everything to do with tornadoes in Oklahoma, obviously. That warm air rises is an expression we hear all the time. You'll even hear people say heat rises. But warm air doesn't rise unless cold air squeezes it up. Without gravity, warm air does not rise. So Fred Hayes did this real-life test of holding very still, and then a layer of warm air would form around his still body on the spacecraft, and he could keep warm. It's just, what? It just seems like such just an extraordinary thing. And if you get in a zero-G airplane and fly these parabolic flights where the airplane goes downhill, as they say, at the same speed as it will fall, you can't run the test. You only got 30 seconds. Because if you don't, pull up, you'll have direct trauma with ground. So whenever I hear Fred Hayes' name, I think about that report. Just what a cool insight, or warm insight that was. And so you don't get thunderstorms and hailstorms and tornadoes without gravity. Something to keep. Thank you, Bill. Wow.
We could spend the whole time just talking about the astronauts with connections to Oklahoma, but the book is largely about all the other people who contributed to the space program in the United States, and some of them are women, like this woman, who we know very well at the Planetary Society. She used to be one of our board members, I believe. A good friend has been on Planetary Radio several times, and that's Donna Shirley, who was, she was a girl.
Donna Shirley, if you read the book, so my girlfriend and I, we wanted to go flying, so the plane, it was too heavy, but it was fine. We took off, just went under the power lines. She flew under the power lines, like this, teenage people. She'll be fine.
She shook things up a lot. I mean, when she went into NASA, there weren't a whole lot of women trying to be engineers.
She was the only female engineer at JPL when she joined.
And so she became a big marketing market, and she wrote a book, Managing Martians.
Yeah. And went on from there. I mean, she was doing stuff at NASA HQ, right?
Yeah, and she started early. When she enrolled at OU, she went to engineering school, and she went to talk to them about enrolling, and they said, girls can't be engineers. Of course, this is the early 1960s, late 50s, and I think she kind of proved them wrong. What do you think?
Oh, yeah.
Not very important, but she also won a beauty contest. I mean, she was.
I didn't know that.
Well, that's what she says. I went there. But she still is an extraordinary person. She's really cool.
Yeah. All right, so here's one of the more traditionally thought of engineers from that period. And there are a lot of reasons to love this picture. One of them is, look at that ashtray full of cigarettes right next to delicate electronic equipment that was probably monitoring somebody on orbit. Who is this?
This is John Aaron. He's probably the most famous person in mission control. Maybe it's next to Gene Kranz. But
Chris
Kraft was mission control. But John Aaron was econ, electrical and environmental systems. And he saved the Apollo 12 mission because he remembered a switch that needed to be flipped after the spacecraft was struck by lightning. And they had no readout at all. And it was time to abort. And it was rapid launch. And he told them to switch. They flipped it and went on to the moon. And then on Apollo 13, he led the group that figured out how to get enough electricity to get home.
Yeah, but the simulator was so well made that they could throw switches or engage systems in the right order so they wouldn't overload it. And the simulator was so accurate that he worked out, I guess, a very complicated sequence.
Yeah.
That required, as the saying goes, one test is worth 1,000 expert opinions. Oh, take my word for it. No, I won't take your word for it. I'm going to try it. So, way to go. Thank you.
These are the engineers, of course, who made sure that all the equipment was working, save the lightning strikes. But, we're the Planetary Society, don't we? So we care a lot about planetary science, and here's one of those planetary scientists.
Ben Clark, worked for Lockheed Martin, Martin area. Before that, he was the planetary scientist for them, and he worked on a lot of missions, a lot of the space probes. Folks in this audience, and some people around the country might know, his family's business was a jewelry store, and it's B.C. Clark, if you're familiar with that.
Everybody knows Virginia.
Got a few customers over there.
The Christmas jingle is known around the country that they play every year on their commercial. And Ben is the third generation Clark, and he knew as a young man when they gave him a pocket watch, he proceeded to take it apart. And they knew then he wasn't going to be in the jewelry business. So
was he able to get it back? That's the question.
I'm sure he did. I'm sure he did. He sure was that good.
I forgot that we've got one more astronaut here. Somebody who has been active a little more recently than some of the others that we've looked at. Shannon Lewis,
amazing woman. She spent more time in space than anyone up till that time on the Mir space station. A series of events kept them from coming and getting her, and no problem. She just stayed.
I want to come home. Sorry.
Hurricanes.
So for the young people, Mir was a Russian space station before the International Space Station, and it was up for years and years. Flying all sorts of people, did all kinds of space research aboard.
There are scores and scores of more people like this. We'll flash one by very quickly. This guy, John Harrington, obviously doing an EVA there, the International Space Station?
Yes, he attached the P1 truss to the space station, which was built in Tulsa, Oklahoma.
That's great. Yeah. And he's an Oklahoman and a Native American.
He's the first Native American in space.
Yeah. Obviously, Oklahomans have a lot to be proud of in the space program. What is it about this state? Why have we seen so many people in every facet of the space program come from this state?
It is that pioneering spirit, because you look at the early astronauts, and they were only one or two generations removed from the settlers of this state. That pioneering spirit that brought them here, they took on to the next frontier, as President Kennedy called it. So you have that, and then there's always, like some of the engineers told me, they grew up on farms out in western Oklahoma, and when they were sitting there picking cotton and the sun was burning down on them, they said, I'm going to do something else.
Smart move. Sherry, it sounds like you're in the right place with Science Museum. Do you get to meet a lot of these people or have benefit from these resources?
Sometimes, you just really love your job, and sometimes you really love your job. And a lot of times we are so fortunate, Tom Stafford is a great friend of our museum, and a lot of our artifacts here are Stafford artifacts, and we do get to meet a lot of people and use them as resources. The knowledge that Bill and Walt brings to the table as well, and is just so incredibly valuable for what we do. We are a collecting institution as well, and so on top of all the millions of hands-on things we do, we have artifacts that we put on display, and they come from our friends that are these astronauts that have been part of the space program.
All right, we have a whole other segment that we're going to need to get to. So I'm just going to, one more time, go ahead.
Can I tell you one more thing about Oklahoma?
Sure.
Right now, Jim Bridenstine's administrator at NASA, he's from Oklahoma. Dr. Kelvin Drogemeyer is the presidential chief scientist at the White House Science Advisory Group. He's from Oklahoma. They came from the meteorology school at OU. Congresswoman Kendra Horn is the current chair of the House Space Subcommittee.
And she used to work with Space Foundation, another
That's right.
group in Washington.
That's right. Congressman Frank Lucas from Western Oklahoma District has been on the Science Committee in the House for years and served on the Space Subcommittee. And then Senator Jim Inhofe, who just left the Senate Space Committee, is chair of the Armed Services Committee. And so he's overseeing efforts to work on the Space Force.
So even your politicians are all space geeks.
Yeah, and we don't have a NASA facility in Oklahoma either.
I wonder if that might change. Let me just say, oh, hey, wow, a famous scenery. Bill Moore's book is Oklahomans and Space. I'll turn it around so I can read the subtitle. Chronicles of the Amazing Contributions of Oklahomans in the Aerospace Industry. Sherry Marshall is the president of Science Museum Oklahoma. Thanks again for hosting us here today, Sherry. We are not done. We're going to be back with a couple of terrific scientists from OU, the University of Oklahoma, to talk about Mars and more with Bill Nye. If you'll stay on stage with me, Bill, thank you very much. Please, though, let's hear it for Bill Moore and Sherry Marshall. We'll be right back after this break. Thank you. You guys were terrific. Stick with us. We're going to make a quick switch here, mostly to hand off the microphones, and then we're going to pick up again and talk about Mars with our two scientists. Thank you, guys. First rate. Very good work.
Speaking of jewelry, check out our Planetary necklace.
Go ahead and pull that off. And Nate and Megan, come on over here and we'll get these switched over. These guys will probably help you out. And I think I'll advance the slide.
Bill, do you have an age? No age. You don't need it.
Turn off my mic. Should have done that before I put on it. I'm not even all of a sudden, or not all of a sudden. Thank you, Bill. Great job.
Oh, Ms. Bill, cool. Yeah, show you that.
Yeah.
I got one.
Okay, just another few seconds here, and we'll pick up. Remember, we're going to have that contest. You might win yourself that signed copy of the book, and we have another amazing prize. In addition, I'll show it to you guys now. This is a slightly less amazing prize. You've seen asteroids, maybe you've seen pictures, maybe we can held one. I bet they have one somewhere around Science Museum, but I bet you've never seen this kind of asteroid. That's a rubber asteroid.
Yeah.
And I'm going to let you do the honors of tossing these out. Okay. You have a much better arm than me.
Yeah, sure.
Can I just give you the bag? Okay, thank you. Okay, are we ready to start up again?
Well, are we throwing these out now, or we're going to wait?
No, we're going to throw those to people we answer the questions. You can throw one. You can throw one. We got enough.
At the end,
All right, raise your hand if you want a rubber asteroid.
So, a problem, a huge problem with asteroids is, as we say, it's like looking for a charcoal briquette in the dark. So you catch a glimpse of them with radar or a certain spacecraft, and then you have to predict where they're going to come in. This is a big problem. 3,
There it goes.
1.
So okay, that's it for now. Stay tuned. We're going to give you a chance to win some of those and those other great prizes. Okay, we're ready to pick up.
You win them by answering fabulous questions.
We're still rolling up there, guys, right? The recorder. Thank you. All right, stand by, everybody. We're going to pick up once again. You'll have another chance for a big round of applause right up front here. I'll pull that away from my mouth a little bit since I sound a little loud to myself. Here we go. Stand by. Welcome back to Planetary Radio Live. I'm Matt Kaplan at Science Museum, Oklahoma, with the CEO of the Planetary Society, Kaplan. All right. Do we have any OU, any student grads or fans in the house? Nothing against OSU. We love them too. But both of our next guests come to us from the University of Oklahoma, just south of here in Norman. We wanted to roll them in on the Sooner Schooner, but Boomer and Sooner have the day off. So they're just going to have to walk up on stage. Let's get started. Bill, you can have a seat, and we'll be joined by these folks. The first of them is astrophysicist Nathan Cave. He's an assistant professor in the Department of Physics and Astronomy at the University of Oklahoma. He's part of the worldwide effort to understand how solar systems like our own and others across the galaxy form and evolve. For example, why does a rocky little world like Earth form where it does, where conditions seem to have been just right for life? And why do next door neighbors like Mars and Venus get such raw deals? Maybe it wasn't always that way. Please help me welcome Nathan or Nate Cave. Have a seat. Thanks. Megan Elwood Madden is the Stubman Trace Presidential Professor of Geology and Geophysics at OU. She and her students use lab experiments, field studies, and geochemical models to understand the amazing diversity of planetary surfaces and the atmospheres above those surfaces. As you'll hear, a lot of her work has focused on the red planet Mars. Please welcome Megan Elwood Madden. Very glad that both of you could join us today. And you're in different fields, but your work overlaps. I learned that just from looking at the websites. Even though one of you is an astrophysicist, Megan, you are, would you say a geologist or a geophysicist?
I'm a geologist.
A geologist, okay. And that means you've got one of those little hammers, and you like to go out and break rocks.
I do that sometimes, but most of the time I spend in the laboratory doing experiments with the rocks I bring back and looking at how they react with different types of fluids. And as Phil noted earlier, fluids can be liquids or gases, and what sorts of things, new minerals form when rocks react with fluids.
So you do chemistry experiments with rocks?
Exactly.
And we've had, I told you, Megan, that we've had lately, the last few months on Planetary Radio, it wasn't really intentional, we've had so many people who do this kind of stuff. And that's good, man. It is a good thing, but
you don't have to express.
I'm not complaining. I'm not complaining. But you do simulations. You try to duplicate the way things might be on some of these other worlds.
Well, part of that is because we have these great data sets, right? That the Mars rovers or the orbiting spacecraft tell us what the different minerals are that they're seeing on Mars and also on Europa or even on Pluto. And some of these are kind of funky. And we got to figure out how these funky mixtures of minerals form. So we're doing experiments in the laboratory to see if we can determine what perfect set of fluid chemistry and temperature and pressure we need to form those interesting mixtures of minerals that we're seeing on Mars.
Are they all equal in your eyes, all these other worlds, or does Mars have an edge?
I've spent a lot of time working on Mars. I think it's because it's actually fairly similar to Earth, so it's easier to do experiments in the laboratory to simulate Mars than, say, Pluto. Like, it's really hard to get down to 10 degrees Kelvin. But getting down to 220 Kelvin, that's kind of
so
yeah.
Except that you're talking temperature here, real cold.
Yeah.
Yeah, even on Mars.
Yeah.
And I'm going to pause for just a moment here while I reach over here, and because we're hearing you pop a little bit, and that might help. Okay, that would be better. Again, see, isn't this fascinating, all this behind the scenes stuff? Okay, we'll pick up right there.
Matt, hang on, Matt, let me just ask. So where the minerals come from Nate, that's your business, right? From exploded stars.
Yeah, well, so what I do is basically, I run computer simulations of large ensembles of objects acting under gravity. And so,
Ensembles of objects with gravity.
yeah.
Well, wait till you see some of the little.
Basically, you have lots of asteroid-like bodies and evolved them under gravity for hundreds of millions of years.
It's a video game for 100 million.
Pretty much, yeah. So you can take 100 million years and speed
So
it up.
parents, they don't, your kid could end up doing.
We just lost your mic.
Yeah, we did. Why did we do that?
I don't know.
Don't worry, parents, your kid could end up playing video games for 100 million years.
That makes me realize.
It's kind of, wait, like I said, wait till you see the animations that he's got.
Come up to dinner. No.
Megan, it's gotta help that we know so much about Mars, because we've sent so many spacecraft there.
Right, so we have
Your mic is gone too.
What in the world is going on?
I hope it's not the batteries. Why don't you pull that transmitter off your belt and just sort of put it on your lap? That might help.
I'm open-minded, but skeptical.
Assuming you have the belt, which I bet you don't. Okay, that's better. Let's see what happens.
okay.
No, still out?
Is it
Okay.
still in the on position?
It's still green.
Yeah, we may still need,
Person up
we might need new batteries.
In the booth, is it amplifying?
Guys, you think we should, it is still, okay, I'm real loud. I don't know why.
I'm taking my volume.
Showbiz. I guess I did. I guess I stole it from you. All right. Talk a little bit more.
How are we all doing today?
Tap, as
Are you getting it now?
It's
Yeah.
working, so
It's
maybe
working
we
now.
moved it too far away from my mouth.
mine
Okay.
doesn't seem.
How's that?
These things happen. All right, let's see if we're going to be okay now. We'll pick up. Again, hopefully the audience will know about any of this. I asked you, is Mars best to study? Oh, pull that back a little bit again, just a little, because we're getting that popping.
Okay.
Okay, because we have so many spacecraft there.
Yeah, we have a huge amount of data about Mars. In fact, we have so much data that there aren't enough human hours to analyze all that data that we have from Mars. But the data that we do have is really fascinating. And we see these unexpected results, like perchlorates, for example.
I hate perchlorates. I hate, especially Martian perchlorates.
Why do you hate perchlorates?
Because they messed up the Viking spacecraft. Well, that hurts us.
So perchlorates are these really highly oxidized chlorine-bearing salts. And we weren't expecting to find perchlorates on Mars.
May I ask you, so to be a perchlorate, I think it means heavy duty, through and through.
Right.
Chlorine.
Mm-hmm.
And then it's a salt.
Right.
So I'm expecting in the land of salts, if there were such a place, I'm expecting
Mars,
something from, Mars. I'm expecting something from the right-hand side of the periodic table and something from the left-hand side. Do I have that?
Yes.
Perchlorate?
In your perchlorate, yes. So the perchlorate is the anion side.
Oh, the anions, there, yes.
Table.
This is the guy, by the way, with the periodic table on the back of his business card.
Okay, so hang on a second. Anna, I remember that cations are positive.
That is correct.
Because they have pause. So anions are negative. So just help me out now. What's going on? I got chlorine
You got 1 chlorine and 4 oxygens.
and 4 oxygens, and that's a salt.
When you add, so that's the anion part of the salt, and then you need a cation to match with it. We're less clear about what the cation is that goes with the perchlorate.
But it could be sodium.
Sodium, magnesium, could be iron.
Could be iron. Could be iron.
But why
What's
haven't
the big
we?
deal?
I mean, we have the Mars exploration rovers. We've got Curiosity there now, especially Curiosity, this amazing rolling laboratory. Why are we still learning about these things? There's just a lot to learn.
There's a lot to learn. Curiosity is amazing in that it can actually measure the minerals with its XRD, right? So not only do we know
What's
the
an XRD?
chemistry,
What's an XRD?
XRD, X-ray diffractometer.
Oh,
Yes. So we can actually tell what minerals are there, not just the bulk chemistry. So we can get down to like individual flavors of different chemistry.
So a mineral is where you take these atoms and arrange them in a pattern.
Correct.
Like a
Yeah.
crystal.
Yeah.
lattice.
And you can arrange the same chemicals in different arrangements and make different minerals. So you can have the same composition that has multiple different minerals.
Same chemicals arranged in a different way. Well, that's the difference between sugar and oil, in a sense, right? Oxygen, hydrogens arranged, the carbon arranged in some charming way.
So I mentioned the Viking spacecraft, Viking 1 and 2, 1976, way ahead of their time. Actually intended to discover life on Mars, but those darn perchlorates got in the way, right?
Right, so the perchlorates, we know now, produced a signal that at the time was interpreted as a possible signal of life.
What was the signal?
It was basically gases that were
Gases,
evolved. Yeah. So, and we were expecting that those gases would be produced by metabolism of organisms, but instead, what we think now, our new interpretation, is that it was perchlorate reacting with either things in the soil or the actual reactants in the Viking mission.
So you can make carbon dioxide with vinegar and baking soda, nothing's alive, or you can make it with your sugar and yeast, something's alive.
Right,
Yeah, you get the same gas given off.
And the presence of those perchlorates that are all over Mars in the first at least few meters, right? Not real friendly to life as we know it.
Not as we know it, although there are organisms in the Atacama Desert that can live in environments that have a lot of
Like when you go to have a clean swimming pool, you put chlorine in it because it kills you.
Yeah.
Yes. Salts are not very bio-happy.
Yeah, unhappy bio-wise.
Yeah.
But let me ask us this. When you are forming solar systems, and there you are out there in your gravity,
Sure.
playing video game for a million years, how likely are you to get chlorine? And then how likely is it to end up on the surface of a planet?
So, in general, in those types of simulations, a lot of the materials, the relatively volatile materials that we see on Earth,
What's a volatile?
oh, something that gets vaporized at a pretty low temperature.
Like, for example,
Water.
Water.
Yeah. That's
not iron.
not iron. No.
What about, who's in between water and iron? Aluminum?
Is aluminum more or less volatile than iron?
I'd ask somebody, I'd have to ask some
Is it less? Okay, thanks.
Maybe somebody from Oklahoma.
Yeah. So anyhow, a lot of those materials actually get thrown in from a little bit further away from the sun, and what we think, I mean, so Earth got a lot of its volatiles probably from the outer asteroid belt, and they were tossed in via Jupiter's gravity, and
Tossed in Jupiter's gravity.
and so Mars will catch a good fraction of that material that gets tossed Earth's way too.
With its gravity.
Yes.
Holds in chlorine, in this case.
Yeah.
And then there we have chlorine all over the surface. Why don't we have chlorine all over the surface of the Earth?
So most of our chlorine is in the ocean.
Well.
So if we evaporated off the ocean, then we would have a lot
And
of chlorine.
so, I just now caught up with you, I apologize. Everybody knows what sodium chloride is. It's table salt. Not everybody, I hope a lot of us. Sodium chloride is what makes the ocean salty, for crying out loud.
Or at least most of it, yeah.
Yeah, and so there's a lot of chlorine.
Yeah.
And you study these brines all over the place, but on Mars, I mean, as Bill said, that's a salt, even though we may not fully understand its composition. And you've got a slide. I'm not sure if this is a good time to bring this up or not. But for the folks who are here, there it is, and I'm sure you know what you're looking at even from this distance. But tell us about it. What are you representing here?
So just like we add salt to an icy roadway in order to get that ice to melt, and those of us that live in Oklahoma, we experience ice storms at least once a year, and hopefully they remember to put the salt out. So we put the salt out before the ice storm so that we keep that water liquid, right?
How
So
does
that it
that
doesn't. The water has a polar molecule, right? It has one end that's more negative and one end that's more positive,
Like a magnet, only
except
except
a molecule.
Except
yeah.
a molecule.
And when we add salt to the situation, the salt breaks up. So if we have sodium and chloride, this halite, which would be the mineral form of this table salt, dissolves into that water, and we have a positive sodium ion and a negative chloride ion. And those actually go in and arrange themselves around the water molecule and basically prevent the water from crystallizing into ice.
From catching on to another water. That's cool.
Yeah. So,
it's very cool. Yeah, it's cold.
yeah, and in fact, if we add enough salt to that water, we can keep that water liquid down to 220 K, which is about the average temperature that we see on the surface of Mars. So if we have liquid water on the surface of Mars today, which there is mounting evidence that there is liquid water at some point somewhere on the surface of Mars today, that water is probably really salty.
So on the surface and also not too
So
far below the surface.
So if I'm driving around on Mars with the right rover, near the equator, I presume,
Probably,
during the
yeah.
summertime, the Martian summertime, I would find a little puddle of briny water.
You
Right
might have
under
a
the
trickle.
A trickle of
You might
salty
have a
water.
trickle, yeah.
Peoples, listen to me, peoples. If you have a trickle of salty water on Earth, you have something living in it. Some crazy
Exactly.
way, some
Anywhere
virus.
there's what, liquid water and a source of energy, right?
There's going to be living things. So I'm telling you.
So,
And if
and,
there's some place on Mars we should send a rover with the right thing to go sniffing around.
Exactly, yes.
and that's exactly what the 2020 rover, not yet named by a young person, although they're headed in that direction, as Curiosity was, that's what it's supposed to do, right? You must be looking forward to that.
Yeah, in fact, I'm really excited. Just like Curiosity was the first rover to take an X-ray diffractometer to Mars, the 2020 rover is going to be the first one to take a Raman spectrometer to Mars. And a Raman spectrometer is a really powerful tool in that it can measure the composition of a liquid, a solid, or a gas, and it can look for these anions that might be dissolved in a brine. So if this rover happens to find one of these trickles, we can shoot it with the laser, because that's what we do in our lab, is we shoot things with lasers.
Come on, we take ray guns to another planet. Oh, that's cool. So then you shoot it with a laser and you...
And we make it glow a little bit, and we collect that light, and that light tells us the composition of that brine.
Yeah, the different atoms, the molecules rather, produce different patterns of light.
Exactly, yeah.
Very cool.
Yeah. That's amazing. So, we're gonna, we needed to name this rover in 2020. Let me interject that the Planetary Society has a long history of sponsoring these contests. So when it revs up, we hope to be sponsoring a contest to name the rover, which is just now called the Mars 2020 rover. It could be a little more creative than that.
And this is something we have a lot of experience doing in collaboration with NASA, so I hope we get that opportunity. I think it's probably fair to say that a lot of why Mars looks the way it does now, and why it may have been a lot friendlier to life, as far as we can tell billions of years ago, is because of where Mars is, right? And that's what you study, Nate. It's a part of what you study.
Yeah, and so we're trying to figure out how rocky planets like the Earth and Mars form. And so our general idea is that, our general picture of things are that you start off with enormous numbers of bodies around an early sun that look something like the asteroids, maybe a billion, couple tens of
So hang
billions.
on, the sun forms first?
Yes. And then within a few million years, probably even less than that, you have formed the dust that's in the disk around the sun after it forms. So the sun's surrounded by a disk of gas and dust.
And we get a disk, this is something I think I understand. If you bring in stuff from every direction with gravity, the likelihood that it would just form a perfect sphere is very, very low.
Yeah,
Instead, there'll be some unevenness, some asymmetry in this pulling in together, and then it resolves itself into a spinning disk.
Yeah, because any random cloud of gas out in the Milky Way is going to have some small net rotation in some direction. And if you take any random cloud of gas and collapse it under its own gravity, you conserve angular momentum, which means that the thing stirs up.
So you can't see this if you're listening to the podcast, but everybody here has his arms out, going like this, and making it spin like this. See how it's going here?
Now I get it.
Yeah. But it goes, but just like the ice skater pulling his of her arms, and the disk spins faster. And faster.
Exactly. You could imagine if you're the ice skater and if somebody spun you up even faster, your arms would go and fly out from your side, and that's basically what happens at the sun's equator. Material has trouble, sticking to the center of the system, and you wind up with, a compact star along the north, basically the north and south poles, the spin axis, but it's much more elongated and disc-like along the equator.
So until 20 or so years ago, we only had one model to look at, our own neighborhood, our own solar system. Now, of course, we are seeing thousands of solar systems, and they appear to be, planets around stars appear to be the rule, not the exception. And lots of them don't look like our neighborhood, right?
Yeah, they look very different. And so that's another challenge, is we thought we had a lot of the kinks in how you form a planet worked out 20 years ago based on our sample size of one. But now when we look at planets around other stars, these are extrasolar planets, we see that you have objects that look something like Jupiter that are right next to their star, and they orbit the star in a day, whereas our closest planet is
really fast.
Yeah,
Fast and hot.
yeah, and then we have planets. The most common type of planet is a planet we don't even have in our solar system, something with a mass between Earth and Neptune. We don't have anything like that. There's a big gap in mass in our solar system.
We have this, the current issue of the Planetary Report, our quarterly magazine, talks about the so-called ice giants, or mini Neptunes.
Yes, yeah, and I don't know where some are called super Earths, other ones are called super Neptunes.
Yeah.
I don't know what.
I didn't, yeah.
Yeah,
Right.
so I think there's kind of
Ice giant would be more like Uranus.
Yes.
I got it wrong.
No, I don't think so. I think some of these seem to have large envelopes of gas similar to our ice giants, whereas other ones seem to have a higher density and are similar to.
Now, when you say seen, can we see that?
No, we can see their transits as they move across their star. The star's brightness dips a little bit, and by the degree that the brightness of the star dims, we can figure out how big the planet is. So we don't see it directly.
Yeah, but then can you also infer that it has an atmosphere?
You can infer its density, which then allows you to constrain what it's made out of.
Of course it does.
So as these bodies form,
Whoa, that's so cool.
almost speechlessly, as these bodies form, and in the incredible diversity that we are starting to see across the Milky Way galaxy, they all affect each other.
Absolutely, yeah. And so that's a challenge. So if you have this is the reason we need to run computer simulations, because if you have just two bodies orbiting each other, Kepler figured that problem out several centuries ago, and you can write down a couple of equations that describe the motion of those two bodies from now until the end of time. But as soon as you can introduce a third object into the system, you can prove that you can't write down a simple equation.
It's the old three-body problem.
Yes, yeah. And so the simulations we run, they have several thousand bodies, and so the way you do that is you know how gravity behaves, and you can model that between any two objects, and you lay down a bunch of objects, several thousand, calculate all their interactions, evolve them in time for a very short period of time, maybe 10 days, look at their new positions and new velocities, and step forward again, and you do that over and over and over. The arithmetic is really boring. It would take a long time to do that by hand, but computers are good at doing the same thing over and over and over again.
Probably still pretty computationally intensive.
Absolutely, yeah.
Yeah, so you need a supercomputer or something.
Yes.
You have some of these here. Should I push go and you can tell us what
Sure.
happens?
So what you're looking at here is you're looking at basically one of these computer simulations. The size of the objects marks its mass, and the color marks its presumed water content, where we've laid down an initial distribution of water. And what you're looking at is the y-axis basically shows how circular the orbits are. If it's low on the y-axis, it's circular like the Earth's orbit. If it's high, it's very elongated in terms of orbit. And the x-axis is the distance from the sun. And so that's the whole solar system there. And you'll notice that when I first learned about planet formation, I thought it's something that happens very quickly, and then you just have the solar system and nothing happens for billions of years after that. But it turns out that our outer solar system has changed quite a bit. The planets have moved around. We know that from studying the Kuiper belt, which is this icy version of the asteroid belt just beyond Neptune.
So Jupiter wasn't always where it is now.
Yeah, Jupiter probably moved about 10% closer to the sun it's 10% closer to the sun today than where it was.
Is that because it's winding down?
It's because it's really good at ejecting these Kuiper belt objects. So objects from the Kuiper belt start to interact with the giant planets, and all the other giant planets, Saturn, Uranus, and Neptune, aren't quite massive enough to efficiently toss them out of the solar system that Jupiter is. So over the history of the solar system, Jupiter has taken lots of small icy bodies and thrown them away from the sun. Now, to conserve, again, angular momentum, during that process, if Jupiter's taking things and putting them further from the sun, Jupiter has to move in slightly. And
Nothing for free.
yeah, exactly. And for the same reason, the other planets have moved out. And we believe that actually caused the giant planets to briefly go unstable, and there could have even been more giant planets than we have today.
So what happens when a giant planet goes unstable?
It gets into a crossing orbit with another planet. And so that configuration is going to change rapidly, and there's a couple different outcomes, 3 different outcomes. One is one of the planets collides with the sun. It gets so eccentric that it hits the sun, or the 2 planets hit each other, or one planet gets exactly, or one planet gets ejected from the solar system completely.
This becomes a rogue planet.
Yeah, and it would be just free floating in the galaxy.
So let me ask you this. How do you feel about Pluto? Pluto's okay with me.
So, speaking of Pluto, which is, we now know, just one of many big Kuiper belt objects, you mentioned this in passing. Do you study those worlds as well? And what about someplace like Titan, which some people think is more like Earth than Mars is?
Yeah, so I do some experiments in my lab where we take a mineral that is very common on Earth, but people don't usually think of as a mineral, and that's ice. Many of you have probably eaten this mineral today. And I look at how that mineral ice reacts with different gases, including methane and CO2, carbon dioxide, to form a material called clathrate, which is basically like a soccer ball cage of water molecules with a gas molecule trapped inside of it. So it's a teeny tiny little soccer ball with one gas molecule inside.
It sounds kind of like, some people here may have heard of a buckyball.
Yeah, kind of like that, except made out of H2O.
Yeah.
Yeah. So I do those experiments in my laboratory where we measure how quickly clathrates form and how long they can stay stable, even if the pressure or the temperature has dropped, so they can stay metastable. So outside of their kind of thermodynamic stability. So stable means if something is stable, it's like the graphite in your pencil is the thermodynamically stable form of carbon.
It's not going
Yeah.
It's just in the pencil.
Right. I hate to tell you folks, but your diamond rings, they're metastable at Earth.
Whoa, metastable.
Right. So carbon wants to be in the form of graphite at Earth's surface conditions. It wants to be in the form of diamond when you're down in the mantle at high pressures and temperatures.
Being smashed.
Down toward the
Yeah.
floor.
Yeah.
Once in a while squirt out through a volcano.
Exactly. So diamond is metastable at Earth's surface conditions, but it can last a very long time.
So diamond rings are slowly turning into pencils.
Exactly. Yeah. Especially if you put it in a solvent. Don't do that.
So what's the solvent for diamonds?
CO2. So
Like in the air?
yeah.
Do not breathe around the diamond.
So if you take water and carbon dioxide and you heat it up, and then you put a diamond in it, you'll dissolve your diamond.
Doggone it, careful out there.
We are getting near the end of the time that we've got for this segment and for our time here at Science Museum, Oklahoma. But I don't want to finish without letting each of you talk about where your research is headed. Nate, you're going to be refining these models?
Yeah, absolutely. So one thing we don't understand about these models, so when you have, say, 4 objects in a simulation, you have to compute all the forces between every single body. And if you double that number, because you have to do all the individual interactions, it goes up by not a factor of 2, but by a factor of 4. And so in these simulations that I just showed before, one shortcut we take often is when we have the Kuiper belt, we don't actually compute the interactions between Kuiper belt objects because it takes a long time. And so now we're just getting to the point where we can actually consider the Kuiper Belt self-gravity and the evolution of the solar system. And just the preliminary work we've done, that probably makes a big difference. And so we're studying that right now.
So bigger, more powerful computers available for less money, helping us learn more about our universe.
Yeah.
Megan, where are you headed with your report?
Well, I've got 3 fabulous graduate students here with me today, and they're each working on their own projects.
Here they are. You guys want to stand up? Give them a shout out here. Future heroes of planetary science. Actually, current heroes.
So Andrew's working to look at how basalts, which are the most common rock on Mars, react with all these different types of brines. John Sue's trying to figure out how rocks in Antarctica can tell us more about potential biosignatures on Mars. And James is figuring out how microbes eat metals, and then new minerals that are formed during that process. So all sorts of exciting things.
Great work, guys.
So in other words, if you found the right metal or compound or alloy or molecule on Mars, it might indicate that there was a Mars microbe in the metal.
Yeah.
Cool. Great work, folks. Thank you very much for being a part of this today. And keep up the great work. And I hope we get to talk to you again on Planetary Radio. Thanks for having me.
Thank you.
Yeah, thanks for the opportunity.
Oklahoma is okay.
We'll do it. Make it safe and make it over with that. And we'll let you keep exit, and then Bill and I will pick up with the contest. Thank you very much.
Thank you, guys.
And make sure your microphone is turned off, and we will pick up here. One more pickup. We'll be done here probably within about 10 minutes. Come on over. All right.
Also, I need to have my throwing arm loose.
Can we get let's get the house lights up if we can, and we'll be able to see who has their hands up and Bill is trying to throw to. Hey, guys.
Yeah, I couldn't see anybody. This is interesting.
Okay, we're going to pick up right here. Stand by. You know what would be very helpful? A little bit of showbiz again. I'll need you guys to applaud, because then I can crossfade from the applause we just heard to the applause you're going to do now. So you ready to help out? Here we go. Just one more thing to do as we finish off this element of Planetary Radio Live from Science Museum, Oklahoma, and that is our contest. Now, normally this contest would be part of the What's Up segment that I have done every single episode for 16 and a half years.
And look, you're fine.
More or less. With the chief scientist of the Planetary Society, Dr. Bruce Betts, another of my colleagues and good friends who works for this guy over here, the CEO. Bruce couldn't join us today, although we're going to hear him in a moment with the regular What's Up. But he did provide some questions for us to use as we turn to the audience here and hopefully throw out a few rubber asteroids. I'll let Bill handle that. So who's ready to answer some questions? All right, stand by. Here's the first one. And don't shout it out. Raise your hand. What native Oklahoman was the first astronaut to make 2 different orbital flights? To fly into orbit around the Earth twice. If you think you know the answer, raise your hand. Somebody with a microphone is going to come over. I see somebody right here in the front. This woman right here. Got a microphone? Great. What's your name?
My name is Trey Thompson.
And I screwed up. I said woman because I can't see you. Sorry. Very sorry, very sorry. Let me take that again. And we're going to go to this person right up here on the front. Hi, what is your name, sir?
My name is Trey Thompson.
And who was that astronaut?
Was it Stafford?
No, it was not. Whoa, let's see those hands again. We have a young person. No, the hand's not actually up. There's a young person with a hand up in the back there. We'll wait for the microphone to get up there. Don't worry, I'll cut all this waiting time out. Here we go. Yes. Hi, what's your name?
What's his first name? Steve.
And, I'm sorry, and who was that astronaut?
Ashton.
So this is Ashton.
Yes.
And Ashton, what was your answer?
Steve.
No, I'm afraid not. There's somebody right in front here. Hi, man.
I'm Joyce and Gordon Cooper.
It sure was Gordon Cooper. Give her a hand. You ready to catch the asteroid? All right, get ready. Here it comes. Well done. All right, here's another one. Let's go to Mars. What are Mars's seasonal polar caps? The ice caps, like the North Pole and the South Pole on Earth, what are those made of, that ice on Mars? What is that ice mostly made of? Here's a young man right in the second row right here. Let's see if he's got it. We'll get the microphone over to him. Hi, what's your name?
Jonathan,
Jonathan, what are those ice caps made of?
was it salt?
No, I'm afraid it's not salt. Anybody else want to take a guess?
We have a lot of salt talk.
Yeah, we have been talking a lot of salt. Hi.
I'm Elisha.
Say that again real loud.
I'm Elisha.
Carbon dioxide?
No, I'm Elisha.
Oh, I'm sorry, that's your name. Sorry, I cannot hear very well at all.
I can't
Anytime.
down here, it's hard.
What do you think it's made of?
Dry ice?
Dry ice, which is also carbon dioxide.
Yes!
You won. And I just know that those, yes, we did get the rubber asteroid. Here's another Mars one. I bet somebody here will know this. What are the names of Mars's 2 moons? What are the names of Mars's 2 moons? There's a gentleman up there in a red shirt toward the back. Right there, I bet he knows. And your name, sir?
My name is Ethan.
And what are those moons?
Phobos and Deimos.
Yes, they are.
Help us out.
That one hurt a little bit.
There's some aerodynamic issues with these rubber asteroids.
Okay. We can do a rubber asteroid for the next one, but I think we're going to do something else as well. And with luck, I've got a picture of it here. Here it is. What you're looking at this is a Mova Globe. And that one is, maybe you recognize it, we live here. It's our own lovely pale blue dot planet Earth. These amazing little worlds under glass combine solar power, and they actually use the Earth's magnetic field to rotate without batteries or any other external source of power. These are planetary images gathered from NASA spacecraft with an astonishing level of detail. Really realistic view of all the planets, moons, other terrestrial bodies. You would normally only have this view looking through a telescope, or if you were up there. We're going to give one away of planet Earth to the person who answers this next question correctly.
You keep it on your desk, and light, like from sunlight or from your room lights, drives a little solar panel inside, underneath the map, as they call it, and that produces a little electric current which repels the Earth's magnetic field, and it just spins all the time. It just sits there spinning. It's so cool.
So incredibly cool. Here it is. Here's the question. What native Oklahoman became one of the first humans to rendezvous with another spacecraft? To actually pull up to another spacecraft in orbit around the Earth. It's not as easy as it sounds. Who wants to guess? I only see one hand up. This gentleman on the aisle right here. Yes, right there. Maybe there was someone else. Go ahead.
Tom Stafford.
It was indeed Tom Stafford.
Tom Stafford,
That Mova Globe is for you. Did you want to add something? What was that? I'm sorry, I can't hear you. You got to use the mic, Richard.
He was asking me my name.
What is your name? Let the world know.
Yes.
Daryl Gray.
Thank you, Daryl.
All right, nicely done.
Okay. By the way, and this is only for those of you who are here in the room, because when people hear this on the radio, it'll be too late. The Planetary Society actually has a contest going on right now that you can enter online, and you could win not just one of these, but the entire 8 planets. Sorry, Pluto. It's the
8
17th.
additional planets, as we like to say. 8 additional planets.
All you have to do is go to www.movaglobes.com planetary giveaway. That's movaglobes.com/planetary giveaway. You've got until May 13th to enter this contest that the Planetary Society is doing with Mova Globes. We have one more prize, and it is a copy of Bill Moore's terrific book, Oklahomans in Space, but very special because it is signed, there it is, by not only Bill Moore, but by General Thomas Stafford, the Oklahoman and astronaut. Okay, and that question is, it's about another Oklahoman. Which Oklahoman astronaut, and you should be able to get this because it was talked about, was one of the survivors of that harrowing mission known as Apollo 13? Who was that Oklahoman who was on Apollo 13 and was played by somebody?
That was up for the other one.
Okay, we'll give it a shot. Why don't we make our way over to her?
Cooper?
No, sorry, Cooper. Let's see, do we have young people with their hands up? I don't know how young you are, but way up there on the top, we'll go to the other microphone and see if she's got it. Hi there, what's your guess?
Fred Hayes.
Who, say it again?
Fred Hayes.
It was Fred Hayes. That's it for the contest here, and it is also the end of our time at Science Museum Oklahoma. We want to thank Sherry Marshall, President of Science Museum Oklahoma, and all of her great staff who supported us here today. And all of you, the people of Oklahoma, you Sooners, thank you for making us feel so welcome. We'll break away here and go to What's Up with Bruce Betts, and then come back. Let's go to Bruce now and do What's Up, and then we'll come back and say goodbye. And here we are now ready to say goodbye, so I'm going to take that again. We're going to do almost exactly that again. I just feel like Calvis has to work.
You should produce a radio show.
I should get good at it. Here we go. So, thank you to Sherry Marshall, the President of Science Museum Oklahoma, who supported us today. And thank you to all of you, you Sooners from Oklahoma. Let's hear it. I also want to thank the terrific guests who joined us on stage, and my co-host for the afternoon, Barrett. Planetary Radio is produced by the Planetary Society in Pasadena, California, and is made possible in part by its proud Sooner members. Mary Liz Bender is our associate producer. Josh Doyle composed our theme, which was arranged and performed by Peter Schlosser. I'm Matt Kaplan, at Astra.
And thank you to the Planetary Society for coming here.
See you very soon.
And we're only 11 minutes late. Thank you, everybody, for staying with us. I hope you enjoyed the show. I will tell you, now the problem was that, whoop, did he take the bag? Hey, Bill, grab the bag. Sorry, I gotta hang on to that.
Well, I wasn't going to take it, man.